Sure. Hi, all of you. Am I audible? Okay, cool. So I'm Shubha Ramachandran. I've been living in Bangalore now for over 25 years. And I work with a group. We are called the Biome Environmental Trust. It started off being a group of volunteers, but now we are a formal NGO. We are also a company that really looks to see how it started off with seeing how does our city manage its water, right? For each city, let me get a sense for where all of you are from. How many of you are from the northern states? We can, okay. And the southern states? Okay. So sitting that way as well. East? East could be anywhere, Bihar, Jharkhand, West Bengal, northeast states. Few of you all from the east. And from the west, Gujarat, Rajasthan. Okay, so there's a fair bit of representation. Very nice. So because we started off in Bangalore, we were thinking, where does our city get its water from? Yeah, there is a water supply authority, as it is with most of our cities in the country. But how far away does it come from? How much energy goes in bringing that water to us? And what could be the other sources of water which can come to us with lesser energy? And you all would have studied about it. There's rainwater harvesting. So that's what we started off. This was early in the 2000s, when it wasn't spoken about so much. The water problems weren't as severe as they are today. And what we realized is that if we want to speak to people about rainwater harvesting, we have to do it ourselves. And ourselves in the sense, we have to work with plumbers, sometimes with well diggers, and see how do you implement this? What are the challenges in implementing? How much does it cost? The harvested rain, what do I do with it? Can I drink it? Anybody? Can't drink rainwater. After purification. Directly, if I open my mouth and the rain fell in? No, still can't drink it. We'll come to that. So those were the questions. Is it to be filtered? What kind of filtration? And we have to do it ourselves, right? I have to go test it in a lab. Otherwise, I can't tell anybody for sure whether you can really drink it or not drink it. And you would have heard of acid rain, several other things that one hears of, but doesn't really know for sure, because these are things we hear, but we don't try it out ourselves. So the thought was, we have to do each of these things ourselves, not just rainwater harvesting, a bunch of other things I'll speak about. Know for sure what it is, and then build an ecosystem. And when I say ecosystem, it's about policy. So government should say, yes, you have to do rainwater harvesting, right? Once government says it's a policy, but people don't know how to do it. So you have to tell them how to do it. Once you tell them how to do it, who will do it? You and I can't do the plumbing. So you need good plumbers who are trained to implement it. So you have to have plumbers. You have to have the water testing laboratories. You have to have good stories that you can tell everybody. So that's how our group came about. We registered ourselves only in 2009 as the Biome Environmental Trust. We work on a bunch of things. I should specifically speak to you about this campaign for 1 million wells for Bengaluru and some other work that we do with children. That's a short movie. We just watched the movie. So just a glimpse of all the kinds of things that we do. We work not only in urban areas, in rural areas as well. We look at water and sanitation. When we say sanitation, it's about what kind of toilets do we have? What happens to all the stuff that comes from the toilet? Where does it go? What energy? You may have heard of sewage treatment plants. Here also there is a large sewage treatment plant. What energy goes into treating your wastewater? Do we need to treat it as much? Can farmers use it? And those are some of the questions. Those of you who are studying science, we are working with a couple of senior biologists to also see what impact does it have on our health. So if I take wastewater and use it to irrigate my vegetables, the vegetables could vary from potatoes to greens to broccoli to corn. And each of these, is there anything harmful that can come to us? You read a lot of reports, but really does that happen? So just to tell you, we work on water, sanitation, we work in urban areas, rural areas. A lot of the work that we do is also around creating awareness and speaking to different kinds of people, be they be plumbers, farmers, students, teachers, architects. We're also doing a lot of talking. So a short quiz, since we are all from different parts of the country. This question is for the Western people. What is this and what do you call it in some of your local languages? And where do you think this is? No. But what does it look like? You may have seen it in your history books. Some pictures that look like this. Huh? Sorry? Yeah, it's a well. Yes, it's a well because you're talking about the million wells for Bangalore. You've heard of Dholavira, Lothal, Indus Valley civilization. So this is actually a well from the Indus Valley civilization found in Gujarat in Dholavira. Okay. Now, and it actually still has water in it. You can imagine how dry it is in Gujarat and the desert, but still there is water that is found in it. This is for the east zoners. Where do you think this well is? This is also a well. Very nice. Where is this? These are all really ancient wells. How many of you have seen a well like this? Not like this, any kind of well. Have you all seen a well? Raise your hands high so I can see. All of you have seen. Most of you have seen, let's say. Very good. Have you all, how many of you have drunk water from such a well? Fair number of you all. Regularly? Do you have a well like this in your house? How many of you? Just quickly call out which city or town do you reside in? Bihar. Okay, this one is for you then. You have to tell me. Sorry? Yeah, Bodh Gaya. This is in Bodh Gaya. Yeah, so this well, it's believed that Gautam Buddha could have drunk water from this well. That's how ancient this well is. Okay. And those are the rock edicts of Ashoka. Just to add to that, if you look at point number RE2, rock edict number 2, the last line said planted trees and dug wells on the roadside. What that really means is that when you dug a well, normally at 10, 15, 20 feet below ground level, in most parts of the country, you could find water which was of a suitable enough quality for us to drink. Now, where do a lot of us get our water from? We'll come to that. Okay, we'll come to that. This southern, where is this? Anybody? Hampi. Very good. This is from Hampi. And this is also a little bit from the west, from the maximum city, but doesn't look like the city it is from at all. Can anybody guess? Maybe from the registration number or phone numbers or something. It doesn't look like the city you think it is. And it is actually a very active source of water, which people don't know. They think water is coming from their rivers or from their Pavai or Vihar lake, but that's where it's coming from, a lot of the water. This is Bombay. Okay, there are wells in Bombay from where water is supplied, drinking water is supplied. This is again, the lower pictures are fairly straightforward. Can you see those? The lower two pictures are from the same place. What is that? Qutub Minar, right? So that's the well at the Qutub Minar. There is water in it, but there's also a whole lot of garbage in it. The top well, just for fun, the other well is from Jharkhand, where that person is taking water and pouring it into the water can. That particular well is actually in Sweden. Just to show you all that there are wells not only in our country, but across the world. These are some pictures from closer Bangalore in very urban areas where there are wells. Can you imagine what the diameter of this well could be if so many people are inside? And if they stood side to side and if each person is about 6 feet this way. So that's the kind of wells that you can have. Can you imagine the volume of water a well like that could hold? I don't have to tell you all. You don't have to imagine, you can calculate it, right? So that's the kind of structures that have been there in our country for long or shorter periods of time, which have been sources of water. Just a few pictures very randomly. This is in a police station. These are all now we're getting pictures closer to Bangalore. Many times you find wells closer to lakes. So there is a lake close by from here. If you all are stepping out, look around the area as well. This was a well that we recently got cleaned in a park that's called Lal Bagh in Bangalore. That's fairly popular. It was an old well, again, full of garbage. We cleaned it out. The well is now full of water. You can get a sense of that's our biome team and the well diggers who helped clean it. Various places, wells, but you find a lot of wells. This is below a very heavily populated flyover. It's called the City Market. And there are wells in broken down conditions like this as well. So now, why did I speak to you about all of this? Why does this matter? Some of us have seen wells, there are some wells, many things are there, right, in our country. There are roads, old roads, broken buildings, all of that is there. So why are we talking about this? We'll come to that. That's because if you look, this is a graph that tells you about how groundwater has been consumed over the years from 1940 to 2010 across these various countries. What has been the rate of extraction? That's in cubic kilometers per year. What you see is that if you see India, that's our brown line, that just takes off from the 1970s. So earlier we were much a consumer like everybody else, relying on water that came from open dug wells. But ever since the technology came around for drilling bore wells, which are borewell rigs that can dig much faster. Normally a borewell is only 6 inches in diameter, goes much deeper. Unlike an open well, which sometimes, what are the things, those of you who've seen open wells, can you tell me a few things about why you use water from the well or why you don't use water from the well? Anybody, why you're not, you had a well, you're not using it, something's wrong. What kind of polluted stuff? So people are throwing stuff, but you can't throw into a borewell. Why can't you throw? Because it's a very small diameter. You can hardly even look inside it. This is easy to throw, so we throw here. What else? Many times a well also dries up in summer because the water level is going up and down. It's what is called the shallow aquifer, yeah, which is open to atmospheric pressure. And then we have to know a little bit of the geology to know why borewells continue to yield water, because they are typically in hard rock and the water is not open to the atmosphere. So we're able to draw water out from the borewell even in summer, whereas the open wells kind of rise and fall. So the important thing in our country and why it's very critical here is that the extraction that we're doing for groundwater is more than the combined extraction of groundwater by both US and China put together. So just in our country alone, we are extracting more groundwater than the United States of America and China put together, and they are the biggest other extractors of groundwater. So obviously, what does that mean? Groundwater is a replenishable resource if we keep replenishing it. Otherwise, we are going to run out of it. How deep are the bore wells that we dig now? Anybody knows? Any of you all, do you want to guess or think about it? 500 feet, okay. Anybody more than that? Yeah, but just tell me, what have you, he's seen a 500 feet deep borewell. Anybody else? How deep? Sorry? Yeah, you can say it in meters or feet. Doesn't matter. Don't hesitate. Just tell. 50 meters. 50 meters, about 150 feet. So he's already greater than that. 500 feet is where he is. Anybody deeper? Does it go to 1,000, 1,200, 1,300? Do you all know of borewells that you all have? Anybody has a borewell in their house? Or in their society or wherever in your neighborhood? Raise your hands. How many of you all have seen a borewell? Okay. Do you know how deep it might be? No. Okay, doesn't matter. When you go back home, try and find out. The deepest borewells are now going as deep as 2,000 feet. And the thing is that as you go deeper, you may strike water. Because why do you strike water? Because nobody else has pulled out water from those depths. So whoever has more money or more technology is able to go deeper and bring the water out from there. But there isn't a whole lot of water there. The borewells that can still be recharged and reused are like what he said, in the 500 to 800 feet. Those are the depths at which the borewells can still be recharged, still be used. But really what is even more replenishable and usable is our shallow well. And that's really the point that we're trying to make, and we'll come to that. So the other thing that we don't talk about, we think all our water comes from rivers, dams. We have Ganges and Narmada. Those are the rivers, right? But if you really look at it, rural India, 80 to 90% of the water is coming from groundwater. Yeah. And if you look at agriculture, 60 to 70% of agricultural water uses groundwater. Cities, 50 to 60% of water use is groundwater. So unknown to us, and not only that, whether they be animals, and these are a bunch of other pictures, the dependence on groundwater is much higher than we imagine, and hence the need for people to know and talk about it, because otherwise we don't know, right? And what we don't know, we think does not exist. And anyway, our underground water we can't even see. So since it's invisible, we know there's a bore well, we don't really know how water comes from it. We don't know at what depth it comes. There's a lot that we don't understand simply because it's invisible. But it's important to know that groundwater is a major source of water for all of us. And it's not only a source of water, but it's also a sink. What we put into the ground goes into the ground. What we take out is also coming out. So like she said, water in the bore wells, in the open wells is sometimes dirty, not only because of solid waste we threw, but also liquid waste that could be dumped somewhere else when we have a soak pit or a septic tank. So yeah, this is all some of the statistics around it about how many 56% of class 1, class 2 cities are dependent on groundwater, just to give you a sense. But however, whenever a city is being planned, people always think of damming a river and bringing water from a river. Nobody really plans and thinks about groundwater. So what was said in 2020, the Niti Aayog had said that both Delhi and Bangalore would run out of groundwater. And like any other city in our country, water comes from really far away. In our case, it comes from a point 100 kilometers away from the city. When there is summer, there are people queuing up for water. When there is rainy season, we flood, right? And so then that seems quite stupid, really. That isn't that so many of us that do complex science, can we not just manage this? And what is it that really keeps us from doing something as simple like that? At the same time, what's really changed? All was well. We still have wells like this in some parts of the parts of Karnataka. So all was well. That's because the city was not as built up. When rain fell, a fair bit of it was able to go into the ground. And extraction wasn't as much because not as many people were living here. So now what has changed? We've built up. When we build, then we crust up the city, so there is no place for the water to go in. And at the same time, we are also extracting more water. So we're not allowing it going deeper, taking out more water, putting lesser in. So obviously we're going to run out of water. And then we have the problem of water scarcity on one hand and urban flooding on the other. Much like what I told you, what has changed is this. There are a couple of things that have changed. As our trees have gone off, the canopy interception is gone. So water falls on the ground much harder. So, and hence you have a lot of erosion also. So you lose soil and you lose water. So the surface runoff has increased. What used to flow as an interflow. So what's called, so base flows and interflows are flows that happen of water below the ground, which we do not see. In fact, a lot of rivers, even though we see a river flowing, even when the river dries up, if you go and dig by its bank, you will find water, right? So water really flows below the ground. When below the ground, it's completely saturated, that's when it comes above the ground. That's why even adjacent to a river, so the river on the face of it may be dry, but there is water flowing underground. But when we keep extracting groundwater, we are drying up our base flows as well. So that's what has really happened. To add to the problem, we are digging these bore wells that go deeper. And in the meanwhile, we've forgotten all about our open wells. So what all has happened, we've crusted up, we're taking out more, we're putting in lesser. Not only that, we just forgot. Most people now, if you would see, would close these wells and build a house on it or something. So it's not of much value to them. So that's the extraction that's happening as we've extracted. So this a little bit about the geology and why we need open wells or how we should be doing recharge. Since some of you spoke about it, the top soil is about 10 feet. Okay, any water that goes over there does not contribute to groundwater, but it is lost to evapotranspiration. Plants can draw that water. Below that is what is called the weathered zone. Then the fractured zone. The weathered zone is only up to about 350 feet. Then the fractured zone, what he spoke about, 500 feet. You have lots of cracks and fissures from where you can get water. This is not to scale, but as you go deeper, when you go into bedrock, there are no cracks and fissures and there is no water at all. And that's quite known. How deep is it to the center of the earth? Anybody? What's the circumference of the earth? It's 40,000 kilometers this way. So what's the center of the earth? We've not got all that deep. The deepest that anybody has ever dug is someplace in Russia where they've gone down 12 kilometers. Yeah? So yeah, that's how it is. But if you look at, so the important thing is we have to see the math here. So this city gets 970 millimeters of rain on an area of 1200 square kilometers. That is our city. It translates to 2500 to 3000 million liters per day. So that means it's the equivalent of 3000 and 365 million liters of day per day is the rainfall that falls on it. Our daily water requirement is only 1500 million liters per day. So what that means is we are getting double of the water that we really need, except that the rain doesn't fall all over the year, but falls only in certain parts of the year. On an average, we are extracting 600 million liters per day. Groundwater is being extracted at the rate of 600 million liters per day. Every day, we are putting in somewhere between 100 to 200 million liters per day. That means we are depleting our aquifers by anywhere between 500 to 600 million liters per day itself. So if we want to replenish this as well as reduce flooding, we have to put water into the ground. How do we put water into the ground? the stormwater drains, there are houses, all kinds of surfaces which are running water off. We need to put it in structures that are called recharge wells, which go 20, 30 feet into the ground and then saturate the aquifers. They saturate the shallow aquifer first, and then they slowly start to saturate the deep aquifer. What does a well look like? It looks something like this, because a city is already built up. We don't have a lot of space. We can't dig the kind of wells you saw in the original pictures. So these are small, 3 feet diameter, 20 feet deep pits. They are dug by a community of well diggers. This is an ancient community. They were called the Vaddars. Like we said, wells are ancient, right? They've always been there. In fact, they say people started earlier, it is assumed that people lived close to the river because water is accessible. But then after some time, they started moving away from the river. Why do you think they did that? Or how could they do that? Yeah, because the river floods, right? So then you lose your house. So you have to come away from the river. If you come away from the river, every time you need water, you have to walk to the river and back. So what do you do then? Then you dig a pit and you say, oh, here I can find water too. So obviously that's how, and in fact, if you look at this particular city, Bangalore does not have a perennial river that flows through the city always. So there is no perennial source of water in the city, and wells have always been the source of water. And you've had this community of well diggers who are now doing up other jobs like being Swiggy or Zomato, whatever, delivery boys and things like that. But they actually know how to dig a well. What's the time? Somebody? Just give me a time. Where is it? Okay, cool. So that's how wells are dug. It's dug step by step. You dig deeper. Then you place these rings. The rings kind of provide structural stability so that the well does not collapse. And then you cover it from on top. You can have it in parks, in stormwater drains, in houses, in various places. These wells can be dug. And this is what we are doing as a campaign. Just to give you a few instances. This is on a main road in Bangalore that's called the MG Road, just below the metro. So the metro lines also, each of the stations is on 1 acre. There's a lot of runoff. So all this water can be put into the ground wherever it falls. So old wells are cleaned up, used for recharge. This is the home. We'll watch a small video about it. Sometimes also what happens is when you dig a recharge well, put water into it over a long period of time. If it is an area with a shallow water table, the aquifer actually revives and you have a source of water. So there have been people who have disconnected their regular municipal water supply and are dependent now only on open wells for their water in the city. So this is another community on 36 acres. They dug 250 recharge wells. And they did a bunch of other things also, which I shall briefly show you. But groundwater, which was not available at 1,200 feet, is now available at 360 feet below ground level. And can you imagine 250 wells in 36 acres? So it's a high density of recharge wells putting water into the ground. Of course, there is a comic book that we made about it. It's in a story form. And that really comes to the part about water literacy for children. They did a bunch of other things too. Not because when we say million wells, it's not only about digging wells, but it's about acknowledging water as a common resource, and it's a common shared resource. If I dig a well and I find water, is it mine? Not mine. Whose it is? Whose is it? Everyone's. But can I drink it? I can drink it, right? It's like the air above. Is it mine? But I can breathe it. But water, then can I sell it? Can I sell the water? If I dig a well and I get water, can I sell it? If I dig and I found gold, can I sell it, keep it? People do find, right? That's how mining happens. So about water, the thing is, it's still, according to the government, because they're not able to supply water in all places. You would have heard of tanker operators who come and supply water. So obviously they have a bore well from where they're drawing water and then they're selling it. But if they're selling it, it's not theirs to sell. So there are permits. So you have to take a permission from the government saying, I'm extracting so much and selling it. A lot of that does not happen, but there is a lot that needs to be understood and done in that space as well. So think about it as you go along. So they did a bunch of things, out of which their flooding actually stopped once they dug these recharge wells. They used lesser water and they actually started pricing for their water also. How many, those of you who might know, do you know how much you pay in your city for 1,000 liters of water? Do you pay anything? Do you pay a water bill? Yes. How much do you pay for 1,000 liters of water? Every 1 KL of water. Okay, when I buy Bisleri water, let's say that bottle, how much does it cost? That's a 500 ml bottle. That's 10 rupees for 500 ml. So how much is it for 1,000 liters? Quickly, somebody. This 500 ml, right? 500 ml is 10 rupees, you said. So 1,000 ml, 1 liter is 20 rupees. And 20 and 1,000 liters is? So what's wrong with the math? Are we missing something? No, think about it. No, those numbers are true. It is important that you think of those numbers and think of how much we pay for water. We'll say that again, okay? 500 ml, 10 rupees, okay? 1 liter, 20 rupees. 1,000 liters, 20,000 rupees. Are we paying 20,000 rupees per KL of water? Is that really the cost? How much do we pay? 18, 19? So just to give you some numbers quickly. In the city, in most cities, there's no metered tariff. People just pay a standard amount. You don't even know how much water you consume, what you're paying. There's no relationship. Slowly, metering is being, as part of the Jal Jeevan mission, metering is being made mandatory. Everybody will be metered. You have to pay the price of the water that you consume. In Bangalore, water is supplied at 7 rupees per 1,000 liters. Okay, when I buy tanker water, it costs me up to 200 rupees for 1,000 liters, 150 to 200 rupees for 1,000 liters. We saw Bisleri water is at 20,000 rupees per 1,000 liters. Yeah, and the production cost of water, the cost for supplying the water from the river to us, you have to treat it, pump it, just the O&M cost, the operation and maintenance costs itself are about 90 to 100 rupees per 1,000 liters. So there is a lot to be understood about the economics of water itself. Wastewater treatment, we say RO systems. What is the kind of energy that goes into the water? And there is a lot of infrastructure behind all of this. How long is that infrastructure going to last? And then how do we look at water? But the point that we often try to make is open well water. However, you can get it at 2 rupees per 1,000 liters. Once the well is dug, if you manage your aquifer, if you look just at the pumping cost, it comes to between 2 to 3 rupees per 1,000 liters for the pumping cost of water from open wells. This is very quickly a story, and it's in a comic book style in various languages, and I'll show you where it's available. If any of you all would like to go back and talk to other school children in your neighborhood. So that's how, so based on all of this, we thought we did some math ourselves, said our city needs 1 million wells to recharge as well as take water out from. We think we are at about 150,000 wells. We're trying to put them on a map. We're trying to make sense out of it. Obviously, we can't go and dig all the wells ourselves, right? So how do we do it? There's a campaign. So we run a lot of events, workshops. We write in the newspapers, various places we speak about this. We've built this information portal, which is doing quite well. It's called urbanwaters.in. We have bengaluru.urbanwaters.in. Soon we are planning to have Chennai, Hyderabad, Pune.urbanwaters.in, where each city speaks about its water, not as a water supply authority, but as citizens coming together and speaking about best practices. Then we have, with artists, we've been running a lot of campaigns. If you take the metro while you're here in Bangalore, in some of the stations, there are murals that have been made with mud that comes from digging the wells, because you get mud in various colors, light brown, dark brown, gray, yellowish. So with that, the students of an art college called Srishti have made murals to tell the story of Bangalore's water with the mud that has come out. So we also do facilitation, demo projects have to be done. Well diggers, government officials, engineers, architects, everybody has to be trained. We do all of that. And then meanwhile, while we are doing all of this, we also have to understand what is really happening to the aquifer. So we are working with the students of 12 colleges from the Bangalore universities, engineering students, who will help monitor the aquifer and tell us what is the state over a period of time. All of this, however, we also want for it to be an inclusive project. So I spoke to you about the community of well diggers. We are doing it along with them because they really know how to dig the wells. We also want for them to not think that they are plain labor who are just digging the wells. We're also telling them how they can go and speak about this to a larger audience. It could be to an English speaking audience, Kannada, any language, Telugu, whatever language it is that they know, such that they can treat themselves with some confidence as well. And they can speak to you about the aquifer because they really understand the ground in various parts of our city at least. we did an exercise with them to map the aquifers also. So we had a large map of Bangalore, and we said, you tell us how deep did you go in each place, what kind of soil, where there is rock. And with the information that came from that, working with certain other geologists, we could make sense of the aquifer. So that's also an idea. And in this photograph, for instance, this is the metro station I was speaking to you about. So there are artists, well diggers, government officials, NGOs, scientists, a whole bunch of people to come together, and poet. So there is some nice poetry around groundwater and old poems around open wells. So how do you get everybody to come together and drive that common agenda together? We now have the well diggers also on social media, so they can speak about the work they do themselves. Parallelly, another thing I thought I'll just briefly tell you, a project that's happening now in Bangalore, and the government is looking at doing it in other parts of the country. Treated wastewater from the city, 720 million liters per day, is pumped to fill the lakes, dried up lakes in the neighboring drought prone districts. So there's a district called Kolar, which is the adjacent district. There are several lakes which are dry. The lakes in that district are being filled with this water. What we see, that's us at the lake side, as this water flows and fills the lakes, the groundwater tables actually rise. So you can establish this close relationship between surface water and groundwater. We have to watch out for water quality. So these are the questions that we are really trying to know about our aquifers. How do you know how large are they vertically, horizontally? How much can they store? How much can they transmit? What is the quality? How are these connected? How do you recharge? How do you manage our aquifers? So those are the questions that we are exploring. More information here, what I told you about urbanwaters.in. Take a look at the site. And we're also looking for young artists who can help us make good posters and kind of take this message across, because we find a lot of resonance with this particular poster around groundwater. So are there fun ways in which we can send out slightly more complicated messages also, that what we do in our toilet also affects the groundwater, what the scientist has to say also affects groundwater. So there's a whole bunch of people who are engaged in, and knowingly or unknowingly, who are managing the groundwater. So that's our imagination. We like this picture a whole lot. When we think that, can these be swimming pools where all of us can swim, wells that are full of water? And that's the first part of the presentation, because water sufficient, because if you're sufficient in water, you're quite resilient really, in ways that you all can't, I mean, sometimes we can't imagine. So that's about the million wells for Bangalore. Stop here. Then I just have 2 videos to play, and then we can have some discussions. Any questions, comments? Yeah. Solely, no, there isn't. So the thing is, the supply may be from river water. For instance, in Bangalore also, if you ask, they'll say we supply Kaveri water. Actually, they also don't supply. They have a lot of bore wells from where they supply. But normally groundwater extraction is private. So the supply may be from river water, but the extraction will be privately, groundwater is mostly privately extracted, which is why the question of what is the private, is it, so people say, is it a common property resource? Is it a common pooled resource? So those are all important words as you look at it, like in terms of ownership and management. Whose responsibility is it to manage the groundwater also? Because people are okay to extract, but then if it's not there, they say, okay, fine, I'm done. There is no more water. But whose responsibility is it? In Texas, I think they've taken it up in a big way. In Australia also, they have actually, Australia is running through some really serious climate change issues, as you. So groundwater, there also the government, they have a groundwater department itself, which we also have a central groundwater board, but they seem to be working in a much more participatory way. So these are 2. There's an Ogallala aquifer in America that's very well managed. Because they're not able to manage it, but they have all the infrastructure and systems to manage it. It's supposed to be the largest aquifer in North America, runs on the western part, but it's also having quality, quantity issues. But they have large systems to at least monitor it. So Australia and America, the Ogallala. No, European countries are not quite there as yet. Yeah. But they've been doing a bunch of good things. Or so, like for instance, they're looking at the aquifer in the sense, all our stormwater drains. See, at some point, if you look at our drains, the nalas that we have in which rainwater is supposed to run, those used to just be like a channel in the ground. As our cities got built up, people said this kind of channel, what happens? It's very shallow, it will silt up. It normally has this kind of a shape, a bowl shape. So they said this is not sufficient. Water does not flow quickly enough. We have to concrete it. So we started getting box drains. If you see, in most cities now we have box drains covered or uncovered because that accelerates the flow of water. It started in Europe, since you asked about Europe. So Europe built the box drains, then we copied them, we built our box drains. Now they're saying we don't want box drains, don't allow the water to go, and we have to slow down the flow. So they're breaking all their box drains. We have not come there as yet. So I think in some time we'll probably, because the thing is, when the water as it flows, if you're able to manage it, you can allow for it to percolate, and rain does fall, rain does flow. There are places for it to flow. Obviously, we can't. What has happened over a period of time is sometimes when we have large periods of drought or water is not flowing, people don't realize you start to encroach, build on water bodies. We don't even know if you do a proper hydrogeological study, you can identify which are recharge zones and discharge zones. So we are also a group of architects and planners. So now, for instance, if a new township has to be built, you have 100 acres of land. Maybe you have built 1,000 houses. So how do you decide where to build the houses, where to have the park, where to have the shopping center, right? And of course, and you think of all that, but we never think, where do I manage my groundwater? What are the places? So what we say is, any project before you plan, you need to do a hydrogeological study, understand where are your recharge zones, make sure you protect those recharge zones. Don't build there, so that water is allowed to percolate in those parts, such that in the discharge zones, you'll get water. So, and you might have heard that story about New York and I forget the names of the hills. Does anybody know? So New York gets its water from a river that starts from a spring in the hills that are close to New York. And they realized at some point that obviously the hill was a tourist spot, and more people were going there and building their homes there. And that actually started to affect the river flows. So then the city of New York started to pay that particular county to not build in those areas. So it's called payment for ecological services. In India too, in Palampur, this was done. Palampur town gets its water from, any of you are from Himachal? From springs above. So if you build on those springs, or if there's a lot of grazing in the spring area, the springs will not flow. So they paid the village to protect that area so that they could continue to get their water. So there are various stories around groundwater and its management. Any other questions or comments? Anything you want to share? Both Biome Trust, right? And also we are not doing all of it ourselves. So initially we thought, but because again, if you do the math for it, like we have 300 well diggers working with us. So we tried. So the thing is, we are not doing all of it ourselves. We are getting people to do. Some we also do. So it's a group target. It's a community target. It includes digging new wells, reviving old open wells, digging new recharge wells. Digging new open wells also. So reviving, maintaining old open wells, digging new open wells, digging new recharge wells. All three are part of the same category, because each one can actually convert to another. A dry open well, you can recharge in it. A recharge well, once it has water, it can become an open well. You can withdraw from it. So it's really like a bank in which you can put and take water out. At the same time, you have to take a call on quality and when it's appropriate to do that. So the way we are running it is, we don't call it biomes campaign. We say it's the cities campaign. So we're trying to get the politicians, the administration to take ownership of it as well, and people and well diggers and different kinds of plumbers and pipe suppliers. So and corporates. So some corporate will come and say, I want to fund 100 recharge wells. So then they take ownership of those 100 wells. So we are just trying to hold the campaign together. We started it, but if we call it's our campaign, then everybody thinks we'll have to dig and it's only theirs. So the idea is also to keep it participatory and a citizen-led city campaign. And and since you all are from different cities, so there's also an Amrit program that's happening for water sustainability in the country from the central government. So 10 cities have been identified, which are all going to be running, not a million wells campaign, but something like this. So we are also one of the cities in that. You'll hear more about it probably in the newspapers. And so it's going to get, because the central government also thinks now that these are structures worth reviving. Okay, so quickly I'll play a video and then you tell me we can end with that. So the video, if there is time, there's a well on the million wells, and there is a video on, since we've spoken of water literacy, both are short 10-minute videos. So I'll play the one on, so we're working with government schools to build water literacy there. So there's a small video that tells you about how we go about with it. And so it's not exactly related to what we spoke about, but nevertheless related. So you can watch it, we can speak about it at the end. We'll play this one.
India has been a civilization dependent on.
Yeah.
We started the Rainwater Club once we had a personal experience with water shortage during the construction of this house. And we found it raining and water was getting wasted away in the storm drain. So we started to collect rainwater and harvest it, and we used that to build this home. Since the Rainwater Club was an unregistered platform, we had to, for grant purpose and activity purpose, register it, and so we started the Biome Trust. So we work with rainwater harvesting, groundwater management and groundwater understanding, wastewater reuse, something called ecological sanitation systems, and water literacy, whereby we teach children especially how to value water, how to understand the quantity and quality of water which they are using in their immediate surroundings to become responsible citizens with water.
And the way we do the work in schools is we engage with the students, we engage with the teachers, and try and frame the engagement and the conversation around the problems that the school is facing for water, for sanitation.
The initial sessions would involve basic facts around water, so the different sources of water around the school, or what do they use water for, and then the introduction to water cycle. So what does water cycle mean? So after that, so we usually, the second session, we usually make the students calculate the water demand for the school. So depending on their roof areas in the school, so we make the students calculate what is the amount of rainwater they can actually collect from their schools, and how much it can offset from their actual water demand in the school.
So the first thing that we do while implementation of rainwater harvesting system is identifying the catchment. That is the building on which the rainwater harvesting system will be installed. After we do that, then there are downtake pipes. So these downtake pipes are connected appropriately. They are brought together. Then there is a first rain separator that's given, which essentially allows the first few minutes of rain to bypass the rainwater harvesting system. After that, the clean water goes through a filter. This kind of filter is filled with jelly stones of different sizes, charcoal, there is a Netlon mesh, so you can construct it on site. And after the filtration, it goes to a storage system.
ಇದರಿಂದ ನಮ್ಮ ಮಕ್ಕಳಿಗೆ ಈಗ ಕುಡಿಯೋ ನೀರಿನ ಸಮಸ್ಯೆನೂ ಪರಿಹಾರ ಆಯಿತು. ಆ ಮಕ್ಕಳಿಗೆ ರೇನ್ ವಾಟ್ರ್ ಒಂದು ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಾಗಿದೆ. ಈಗ ನಾವು ರೇನ್ ವಾಟ್ರ್ ಮಳೆ ಬಂದಾಗ ಈ ನೀರು ಸಂಪಿಗೆ ಹೋದಾದಾಗ ಸಂಪು ತುಂಬ್ಕೊಂಡು ಹರ್ಕೊಂಡು ಹೋಗ್ಬಿಡುತ್ತೆ. ಆ ಸಂದರ್ಭದಲ್ಲಿ ನಮ್ಮ ಸಂಪ್ ಏನಿದೆ ಒಂದು 10,000 ಗ್ಯಾಲನ್ ನೀರು 2 ಟ್ಯಾಂಕರ್ ನೀರು ಹಿಡಿದ್ರೆ ಆ ಒಂದು ಸಂದರ್ಭದಲ್ಲಿ ಗೌರ್ಮೆಂಟ್ ಟ್ಯಾಪ್ ನೀರು ಬರ್ತವಲ್ಲ ಪುರಸಭೆದು ಅದನ್ನು ಗೇಟ್ ವಾಲ್ ಆಫ್ ಮಾಡಿಬಿಡ್ತೀವಿ. ಅದು ಖಾಲಿ ಹೋಗೋವರೆಗೂ ಮಳೆಗಾಲ ಯಾವ ರೀತಿ ಮಳೆ ಬೀಳುತ್ತೆ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡು. ಹಾಗಾಗಿ ನಮಗೆ ಮಳೆಗಾಲದಲ್ಲಿ ನಾವು ಆದಷ್ಟು ಟ್ಯಾಪ್ ನೀರನ್ನು ಬಳಕೆಗೆ ನಿಲ್ಲಿಸಿದ್ದೀವಿ. ಈ ಸೇವ್ ಮಾಡ್ಕೊಂಡು ಇದನ್ನು ಬಳಕೆಗೆ ಉಪಯೋಗಿಸ್ಕೊಂಡು ಈ ಒಂದು ರೇನ್ ವಾಟ್ರು ವ್ಯಾಲ್ಯೂವನ್ನು ತಿಳಿಸ್ಕೋದಾಗಲಿ, ನಾವು ಮೇಂಟೆನೆನ್ಸ್ ಮಾಡೋದು ಎಲ್ಲದು ಹೆಡ್ ಮಾಸ್ಟರ್ ಆಗಲಿ ಟೀಚರ್ಸ್ ಆಗೋದು ಕಷ್ಟ. ನಾವು ಕ್ಲಾಸ್ ಮಾಡ್ತಾ ಇರ್ತೀವಿ, ಅವಾಗ ಏನೋ ಬರುತ್ತೆ. ಹಾಗಾಗಿ ನಾವು ಸ್ವಲ್ಪ ನಮ್ಮ ವರ್ಕ್ ಲೋಡನ್ನು ಕಡಿಮೆ ಮಾಡಲಿಕ್ಕೆ ಒಂದು ಕಮಿಟಿ ಅಂತ 4 ಹುಡುಗರು ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ.
ನನ್ನ ಹೆಸರು ರಿಷಿತ್, ನಾನು 7th ಸ್ಟ್ಯಾಂಡರ್ಡಲ್ಲಿ ಓದ್ತಾ ಇದ್ದೀನಿ. ನಾವು ರೇನ್ ವಾಟರ್ ಕಮಿಟಿಯಲ್ಲಿದ್ದೀರಿ. ನಾವು ಆ ಕಮಿಟಿಯಲ್ಲಿ 4 ಜನ ಇದ್ದೀರಿ. ನಾವು 2 ಮೇಲೆ ಹಾಕಿ ಇನ್ನಿಬ್ಬರು ವಾಟರ್ ಸಪ್ಲೈ ಏನಾದರೂ ಬೇಕಾದರೆ ಎಲ್ಲ ಸಪ್ಲೈ ಮಾಡಿಕೊಡ್ತಾರೆ ಮೇಲೆ. ಅವಾಗ ಕ್ಲೀನ್ ಮಾಡ್ತೀರಿ. ಮಳೆ ಬಿದ್ದು ಮಾರನೇ ದಿವಸ ಅಲ್ಲಿ ಗೇಟ್ ವಾಲ್ ಐತೆ ಅಡುಗೆ ಮನೆ ಹತ್ರ, ಅದನ್ನು ಓಪನ್ ಮಾಡ್ತೀರಿ. ಅದ್ರ ಒಳಗಡೆ ಇರೋ ಕಸ ಎಲ್ಲ ಬಂದು ಆಚೆಗೆ ಬರುತ್ತೆ. ಆಮೇಲೆ ತಿರ್ಗಾ ಕ್ಲೋಸ್ ಮಾಡ್ತೀರಿ. ಆಮೇಲೆ ವಾರಕ್ಕೊಂದ್ಸಲ ಕ್ಲೀನ್ ಮಾಡ್ತಾ ಇರ್ತೀರಿ.
ಮಕ್ಕಳಿಗೆ ಫಸ್ಟ್ ಆ್ಯಂಡ್ ಸಪ್ರೇಟ್ರು ಓಪನ್ ಮಾಡೋದು ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀವಿ. ಅದನ್ನು ಅವರು ಮೇಂಟೈನ್ ಮಾಡ್ಕೊತಾರೆ. ಆದ್ರೂ ನಾವು ತಿಂಗಳಿಗೊಂದು ವಿಸಿಟ್ ಮಾಡ್ತೀವಿ. ಆಗ ನಾವು ಎಲ್ಲ ನೋಡ್ಕೊಂಡು ಬರ್ತೀವಿ. ಏನೇ ತೊಂದರೆ ಇದ್ದರೂ ಅದು ಕಸ ಏನಾದರೂ ಮೇಲೆ ಪೈಪಲ್ಲಿ ಸಿಗ್ಕೊಂಡಿದ್ರೆ ಮತ್ತು ಟೆರೆಸ್ ಮೇಲೆ ಏನೋ ಕಸ ಇದ್ದರೆ ಮಾಸ್ಟ್ರು ಹೇಳ್ತಾರೆ ಈ ಥರ ತೊಂದರೆ ಇದೆ ನೋಡಿಯಪ್ಪ ಅಂತ. ಆಗ ನಾವು ಎಲ್ಲ ನೋಡ್ಕೊಂಡು ಬರ್ತೀವಿ.
Like is often cliched and spoken about children being the future of the country as we go ahead, a need to inculcate in them these values and for them to be able to see how it really works. And many times they take the message beyond their school as well. They take it to their parents, other teachers. So keeping all of that in mind, we started engaging with schools.
ಸರ್ ನಾವು SMT ಇದರಲ್ಲಿ ಸ್ಕೂಲಲ್ಲಿ ಮೆಂಬರ್ ಆಗಿಸಿದ್ರು, ಒಂದು 18 ಜನ ಇದ್ದೀರಿ ನಾವು. ಅಲ್ಲಿ ನೋಡ್ಕೊಂಬಂದು ನನ್ನ ಮಗ ಮಳೆ ಕೊಯ್ಲು ಇದು ಮಾಡಿದರು. ನೋಡ್ಕೊಂಬಂದು ಮನೆ ಕಟ್ಟಬೇಕಾದ್ರೆ ಈ ಥರ ಮಾಡಂತೇಳಿ ಸರ್, ಅದಕ್ಕೆ ನಾವು ಮಾಡ್ಕೊಂಡು ಈ ಥರ ಬಳಕೆ ಮಾಡ್ತಾಯಿದ್ರಿ. ಮಳೆ ಬಿದ್ದಾಗ 1 ತಿಂಗಳ ಬಳಕೆ ಆಗ್ತದೆ ಸರ್, ಅದು ಮಳೆ ನೀರು ಮಳೆ ಕೊಯ್ಲ್ದು 1 ತಿಂಗಳ ಇದು ಟ್ಯಾಂಕರ್ ಏನು ಓಡಿಸ್ಕೊಂಡಂಗಿಲ್ಲ ಏನಿಲ್ಲ, ಮಳೆ ಕೊಯ್ಲಿಂದ ಅದೆಲ್ಲ ಅನುಕೂಲ ಆಗುತ್ತೆ ಸರ್.
But we've not been limited to this area alone. We've done schools in the center of the city, in Vartur, Gunjur, in Kasvanahalli. There's a school near Kaikondrali called the Renuka School. So there have been different donors at different points in time and schools across the city where we've been able to implement rainwater harvesting.
The impact of this particular project can be seen on 2 fronts. One is the physical impact, where the physical infrastructure has been developed. So this has enabled the schools to capture rainwater and use it at different points for hand washing to using water in the toilets, ensuring that hygiene and sanitation is taken care.
Biome is part of a larger canvas of people and institutions who are seeking solutions to India's water challenge. One has seen that water has now become center stage at receiving attention. So we are glad to be part of this broader journey. We are glad to bring the voices of people, farmers, well diggers, plumbers into this whole discourse, and we see hope and optimism. Even though the era of climate change is very pessimistic, we think that a lot of local solutions will help us at least partially alleviate our problems in the coming days.
I didn't set much context for that. I also forgot how long it was. It's a short video. So it's a parallel. So today's theme was water literacy and million wells. So even in literacy, we think that a lot can be done by the doing of it. So I mean, one is to know what it is theoretically, but one is to do it. And when you do it also, it's not about, so for instance, this, sure the video was reasonably self-explanatory. It was about when we go into a school, we talk to the headmaster with the children, design a rainwater harvesting system for them. And we try to get the students involved in the maintenance. We make sure their parents are also, every school has something called an SDMC, School Development Management Committee, in the village, which is made up of a panchayat member, school headmaster, some parents. So that's a group. So you make sure you're talking there. So as much as anything that we do, the need to talk about it, we realize, is quite a lot in various ways. So sometimes we shy away from it, or you think there is too much talking in the world in any case, but that unfortunately is the only way that we can tell more people about what it is that we do. And what you realize is that when you speak and people see reason, so in the school we implemented rainwater harvesting, that then we made the committee, because who would go, that there's something called a first rain separator, filter, all of this has to be managed. So we asked a few children, they got interested, so they would do it every day. Then the others who didn't get to do that, they wanted to have a chance to do that work. They went and spoke to their parents. So the parents said, okay, I'm building a new house, let me do rainwater harvesting. So that's how it spread. So literacy, in a way, it is done that you're really reaching out to as many people as possible. And it's not that we will be able to design it or implement it, but when it's done, then we get to hear of their story. Or a school is there, the neighboring, some houses there, they'll just look to see what's happening in the school. And then they'll call the same plumber and say, what are you doing there? Can you do this for me also? So there are various ways in which these things organically grow. We just have to be, in whatever it is that you do, you can always watch out for opportunities for that. So that was the little bit on water literacy. Since we're doing well on time, if you don't mind, we can watch the other million wells video and then we'll conclude with that.
India has been a civilization dependent on groundwater and specifically open dug wells for more than 5,000 years. The Indus Valley civilization shows us that Mohenjo-daro, every third house had a well. Lothal had wells, Harappa had wells, Dholavira had wells, as well as rainwater harvesting systems. And Keeladi in Tamil Nadu also says that the wells were prevalent in South India too, more than 3,000 years back. India now is one of the largest users of groundwater, with about 250 cubic kilometers of groundwater being extracted every year, making it greater than USA and China combined together. The memory of the open dug well, however, is fast receding with the advent of the bore wells. The open dug wells tap into the shallow phreatic unconfined aquifer. They talk to us. This year's theme of World Water Day is groundwater making the invisible visible. Open wells makes groundwater visible. We are able to see the water in the wells, understand the availability of the resource. As summer approaches, water tables fall, and therefore we have to use water more carefully. As the monsoon season recharges the well, water tables come up, we are able to allow more usage of water. Wells reward us for good behavior. If we recharge the aquifer, the well water table can increase, the quantity and quality of water can improve. Wells punish us for bad behavior. If we dump garbage or pollutants around the well, it can lead to the leaking of these pollutants into the aquifer, and then the well water becomes unusable. Wells are not only functional in terms of providing water, but great communicators. This essence of communication of the ecological availability of water as a resource is what we are trying to revive through focusing attention on the dug well. In Bangalore, for example, there are many homes which depend on wells for water. More than 10,000 homes depend on wells for water. We wish to make sure that the residents who are taking care of these wells become aware of what a treasure they have, that they recharge it with rooftop rainwater, that they make sure that it is cleaned and desilted regularly, and that they talk about the wells to their neighbors, because this well provides them water throughout the year in many cases. The whole movement of focusing on open dug wells is also pan-India now. It is likely that the Amrut project, which touches about 500 towns and cities across India, will try to focus on the shallow phreatic aquifer and make sure that wells in Hyderabad, Belgaum, Banaras, Kolkata, Chennai, and many other towns and cities are also revived and brought back to functional use. Wells are heritage for us. Wells are functional. Wells communicate. Wells provide us the cheapest water. Wells provide us water with the lowest embodied energy. And by focusing on open dug wells, we will be able to retain the traditional water heritage of India and make sure that ecological sustainability is ensured through proper rainwater harvesting and demand management.
ನಮಸ್ಕಾರ, ನನ್ನ ಹೆಸರು BM ಮಂಜುನಾಥ್ ಅಂತ. ಬೆಂಗಳೂರು ಜಲಮಂಡಳಿ ಸಹಾಯಕ ಕಾರ್ಯನಿರ್ವಾಹಕ ಅಭಿಯಂತರು ಹಾಗೂ ಸಾರ್ವಜನಿಕ ಸಂಪರ್ಕಾಧಿಕಾರಿಯಾಗಿ ನಾನು ಕೆಲಸ ಮಾಡ್ತಾಯಿದ್ದೀನಿ. ಈ ನಿಟ್ಟಿನಲ್ಲಿ ನಾವು ಆಲೋಚನೆ ಮಾಡೋದಾದರೆ, ಬೆಂಗಳೂರು ಸಮುದ್ರ ಮಟ್ಟಕ್ಕಿಂತ ಸುಮಾರು 3,000 ಅಡಿ ಎತ್ತರದಲ್ಲಿದೆ. ಇಲ್ಲಿ ಯಾವುದೇ ನದಿ ಅಥವಾ ಸರೋವರಗಳಿಲ್ಲದೆ ಇರೋದರಿಂದ ನಾವು ಸುಮಾರು 100 ಕಿಲೋಮೀಟರ್ ದೂರದಿಂದ ನೀರನ್ನು, ಕಾವೇರಿ ನೀರನ್ನು ತಂದು ನಾವಿಲ್ಲಿ ಸರಬರಾಜು ಮಾಡಬೇಕಾಗುತ್ತೆ. ಆಮೇಲೆ ನೈಸರ್ಗಿಕವಾಗಿ ಬೆಂಗಳೂರು ನಗರದ ಮೇಲೆ ಸುಮಾರು ಪ್ರತಿ ವರ್ಷ 1000 mm 8 ತಿಂಗಳಿಗೆ ಸ್ಪ್ರೆಡ್ ಆಗಿರುವಂಥ, ಅಂದರೆ ಅವಧಿಗೆ ಅದು ವಿಸ್ತರಣೆ ಆಗಿದೆ. ಆ ಮಳೆ ಬೀಳ್ತಾ ಇರೋದ್ರಿಂದ ನಾವು ಮಳೆ ನೀರು ಕೊಯ್ಲನ್ನು ಅಳವಡಿಸ್ಕೊಂಡ್ರೆ ನಿಜವಾಗ್ಲೂ ನಾವು ಸ್ವಾವಲಂಬಿಗಳಾಗಿ ಕೆಲಸ ಮಾಡ್ಬೋದು.
I dug a well and used most of the water or all of the water from the well to build my own house in Vidyaranepura. I also connected my rainwater sump to the well so that whenever it rains, the well gets recharged by rainwater. And I have 365 days of well water available to me at my premises.
This well was dug at the time of construction of my house. Age of this well is around 26 years. But this rainwater, I am using it for last 15 years. I don't waste even a single drop of water. Even though there are about hundreds of borewells, I have no dearth in depth of water level. I never draw water from Kaveri since I am using this water for everything in our house.
So ನಾವು ಇಂದ್ರಾನಗರಲ್ಲಿರೋದು, BWSSB ಲೈನ್ದು ಕನೆಕ್ಷನ್ ಇದೆ. ಸೊ ಕಾವೇರಿ ನೀರು ರೆಗ್ಯುಲರ್ ಆಗಿ ಬರುತ್ತೆ, ಆ ಥರ ಏನು ತೊಂದರೆ ಇಲ್ಲ ಕುಡಿಯೋ ನೀರಿಗೆ ಅಂತ. ಆದರೆ ಬೋರ್ವೆಲ್ ನೀರು ಸ್ವಲ್ಪ ಕಡಿಮೆ ಆಗ್ತಾಯಿತ್ತು. ಅದಕ್ಕೆ ರೆಸಿಡೆಂಟ್ಸ್ ಎಲ್ಲ ಸೇರಿಕೊಂಡು ಇನ್ನೊಂದು ಬೋರ್ವೆಲ್ ತೋಡೋಣ ಅಂತ ಯೋಚನೆ ಮಾಡ್ತಾಯಿದ್ರು. ಆವಾಗ ಅದ್ರ ಬದಲು 2 ಬಾವಿ ತೋಡಿಸ್ಬಿಡೋಣ ಅಂತ ಪ್ರಪೋಸ್ ಮಾಡಿದ್ವಿ. ವಿ ಹಿಟ್ ವಾಟರ್ ಅಟ್ 30 feet. ಇದು ಅಗಿಬೇಕಾರೆ, ಈ ಬಾವಿ ಅಗಿಬೇಕಾರೆ ಮೇಲ್ಛಾವಣಿಯಿಂದ ಮಳೆ ನೀರು ಇಲ್ಲಿ ಬಿಡೋಕ್ಕೆ ಶುರು ಮಾಡಿದ್ಮೇಲೆ ಆ ಕಲ್ಮಶನೂ ಹೋಯಿತು. ಇವಾಗ ಜಾನ್ವರಿ 2021 ತನಕ we were able to draw about 5,000 to 6,000 liters of water every week. ಗ್ರೌಂಡ್ ವಾಟರ್ ಲೆವೆಲ್ಲು ಇವಾಗ ಜಾಸ್ತಿ ಆಗಿದೆ ಬೋರ್ವೆಲ್ಲನ್ನು. ಸೊ ಎಲ್ಲ ರೀತಿಯೂ ನಮಗೆ ಅನುಕೂಲ ಆಗ್ತಾ ಇದೆ.
Most of the houses in APR, especially the ones which have basement, they have a seepage problem, and we were not the different. So we had a basement flooding problem, a big one, where all our media room was all blasted off, right? Basically, we collect the rooftop rainwater, direct it to the recharge well here, and it also works as a withdrawal well. We withdraw the well using the pump system, automatic pump system, and we use it almost 5 to 6 months in a year. So this has been in operation for almost 3 years. So this is the third year, and 5 months are already over. And when I say we use this system, it means completely 100% we are on this system. Just supply water is completely shut off.
हम लोगों ने एक प्रोजेक्ट चालू किया जिसके तहत हमारे पास जो ओपन वेल्स थे, 2 के अलावा 2 और थे, इन चारों ओपन वेल्स जो कुएं हैं उनको हमने रिवाइव किया. हमारा बारिश का पानी जो कि हमारी 191 एकड़ के फील्ड एरिया में है उसको हमने सारा डाइवर्ट किया. वहाँ हमने वेटलैंड्स क्रिएट किए. वो वेटलैंड्स इन चारों वेल्स को रिचार्ज करते थे. और इसके साथ ही हमारा जो BWSSB का पानी था वो हमने सितंबर 2017 में लेना बंद कर दिया. उसके अलावा हमने रूफटॉप रेन वाटर हार्वेस्टिंग और सरफेस रन ऑफ वाटर हार्वेस्टिंग भी काफ़ी बड़े पैमाने पे की. ये सब करने के बाद अब आज के दिन हमारे पास एक्सेस पानी है. हमारा पूरा प्रोसेस वाटर रिक्वायरमेंट जो कूलिंग वाटर रिक्वायरमेंट 2 से 3 लाख लीटर प्रतिदिन का है वो हम इन्हीं सब स्रोतों से पा लेते हैं.
As a responsible corporate, one of Puravankara's main mandates under CSR is environmental sustainability. For us, it was a natural progression to move into water conservation. And as our premier project or as our opening project, we chose Rest House Park, where we are today, which is in the city in Bengaluru. With these recharge wells right now, we are completely using water from them because we were able to do rainwater harvesting from the really abundant rainfall last year. Our dependence on water tankers has completely gone down, and as you can see, it's a beautiful green thriving park right here in the middle of the CBD.
CSR activities mean larger impact, and there's no much larger impact than groundwater recharge. When they see the work that has happened and see the results that come out, they are thrilled and they want to do more and more.
ಕಬ್ಬನ್ ಪಾರ್ಕಲ್ಲಿ 75 ರೀಚಾರ್ಜ್ ವೆಲ್ಗಳನ್ನ ಮಾಡಿದ್ದೀವಿ. ಡೆಪ್ತ್ ಬಂದು 15ರಿಂದ 20 ಅಡಿ, ಡಯಾ ಬಂದು 3 ಅಡಿ ಡಯಾದಲ್ಲಿ ಮಾಡಿದ್ದೀವಿ. ಏನಕ್ಕೆ ಮಾಡಿದ್ದು ಅಂತ ಹೇಳಿದ್ರೆ, ಈಗ ನಿಮಗೆ ಗೊತ್ತಿರೋ ಪ್ರಕಾರ ನೀರು ಅನ್ನೋದು ಜೀವನಕ್ಕೆ ಅವಶ್ಯಕತೆವಾಗಿರೋಂಥ ವಸ್ತು. ಮಳೆ ನೀರು ಬರಬೇಕು, ಎಲ್ಲೋ ಬಾವಿಗಳು ತುಂಬಬೇಕು, ಕೆರೆ ಕಟ್ಟೆಗಳು ತುಂಬಬೇಕು, ಅಷ್ಟು ಬಿಟ್ಟರೆ ಬೇರೆ ಯಾರು ನೀರನ್ನು ಉಳಿಸುವಂಥ ಕಾರ್ಯ ಯಾರೂ ಮಾಡ್ತಾ ಇಲ್ಲ. ಸೊ ಆ ನಿಟ್ಟಿನಲ್ಲಿ ನೋಡಿದಾಗ ನಮ್ಮ ಇಂಡಿಯಾ ಕೇರ್ ಫೌಂಡೇಶನ್ ಕಡೆಯಿಂದ ಈ ಥರ ರೀಚಾರ್ಜ್ ವೆಲ್ಗಳನ್ನ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಈಗ ಕಬ್ಬನ್ ಪಾರ್ಕಲ್ಲಿ 75 ಮಾಡಿದ್ವಿ, ಮತ್ತು ಬೇರೆ ಬೇರೆ ಕಡೆನೂ ಮಾಡಿದ್ದೀವಿ. ಇದರಿಂದ ಏನಂತ ಹೇಳಿದ್ರೆ, ಈಗ ಮಳೆ ನೀರು ಬರುತ್ತೆ, ಮಳೆ ನೀರು ಬಂದಿದ್ದು ಎಲ್ಲೋ ಸುಮ್ಮನೆ ರೋಡಲ್ಲಿ ಅದು ಮೋರಿ ಸೇರೋ ಬದಲು ಬಂದು ಈ ರೀಚಾರ್ಜ್ ವೆಲ್ಗೆ ಬಂದಾಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ, ಭೂಮಿಗಳಲ್ಲಿ ಪದರಗಳಿರುತ್ತಲ್ಲ, ಆ ಪದರದ ಮೂಲಕ ನೀರನ್ನು ಹಿಂಗಿ ಮತ್ತೆ ಅಲ್ಲಿ ಶೇಖರಣೆ ಆಗುತ್ತೆ. ಈ ಒಂದು ಉದ್ದೇಶದಿಂದ ಮಾಡ್ತಾ ಇದ್ದೀವಿ.
ಮಳೆಗಾಲದಲ್ಲಿ ಹಲವಾರು ಪ್ರದೇಶಗಳಲ್ಲಿ ಕಬ್ಬನ್ ಪಾರ್ಕು ಯಾವ ಒಂದು ಸಾರ್ವಜನಿಕರಿಗೂ ಪ್ರಯೋಗವಿಲ್ಲದೆ ಆಗೋಗ್ತಾ ಇತ್ತು. ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಅಲ್ಲಿ ಮಳೆ ನೀರು ಬಂದು ಶೇಖರಣೆ ಆಗುತ್ತಾ ಇರೋದನ್ನು ಅಲ್ಲಿ ಯಾರೂ ಉಪಯೋಗಿಸೋಕ್ಕಾಗ್ತಾ ಇರಲಿಲ್ಲ. ಇದು ಕೋರ್ಟಿನ ಹಿಂಭಾಗದಲ್ಲಿ ಈ ಥರ ಭಾಗಗಳಲ್ಲಿ ಹಲವಾರು RBI ಹಿಂಭಾಗದಲ್ಲಿ ಇಂಥ ಭಾಗಗಳಲ್ಲಿ ಅವರು ಉಪಯೋಗಿಸೋಕ್ಕಾಗ್ತಿರಲಿಲ್ಲ. ಸೊ ಅಂಥ ಭಾಗಗಳಲ್ಲಿ ನಾವು ರೀಚಾರ್ಜ್ ವೆಲ್ಲು ಅಂದರೆ ಇದನ್ನು ಹಿಂಗು ಗುಂಡಿಗಳನ್ನು ಹಿಂಗು ಬಾವಿಗಳನ್ನು ಮಾಡಿದಾಗ ಒಂದು ನಿಮಗೆ ಫ್ಲಡ್ಡಿಂಗು ಕಡಿಮೆ ಆಯಿತು, ಅಲ್ಲಿ ನೀರು ತೇಗಿ ನಿಲ್ಲುವುದು ಕಡಿಮೆ ಆಯಿತು, ಜೊತೆಯಲ್ಲಿ ಅದರ ಬಳಕೆನೂ ಆಗ್ತಾ ಬಂತು ಸಾರ್ವಜನಿಕರಿಗೆ.
ಲಾಲ್ಬಾಗ್ ಮತ್ತು ಕಬ್ಬನ್ ಪಾರ್ಕ್ ವಾಟರ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಹೇಗೆ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅಂದರೆ, ಟರ್ಷರಿ ಟ್ರೀಟೆಡ್ ವಾಟರ್ ಯೂನಿಟ್ ಇದೆ ನಮ್ಮ ಹತ್ರ. ಅದು ನಮ್ಮ BWDSSB ಕಡೆಯಿಂದ ಇದೆ. ಅವರಿಗೆ ನಾವು ಪೇ ಮಾಡಿ ದುಡ್ಡು ತೊಗೊಳ್ತಾ ಇದ್ದೀವಿ. ಸೊ 2 ಪಾರ್ಕನ್ನು ನಾವು ಅವರಿಂದ ವಾಟರ್ನ ಬೈ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಈಗ ರಿಚಾರ್ಜ್ ವೆಲ್ಸ್, ಈ ಇಂಗುಗುಂಡಿ ಮತ್ತು ಬಾವಿ ಇದೆಲ್ಲ ಬಂದಮೇಲೆ ನಮ್ಗೆ ಹೇಗಾಗಿದೆ ಅಂದರೆ, ನಮಗೆ ವಾಟರ್ ಅಂದರೆ ನಮ್ಮದು ಮಂತ್ಲಿ ಬಿಲ್ ಈಗ ಸಪೋಸ್ 10 lakhs ಇತ್ತು ಅಂದರೆ now it is reduced to 5 lakhs.
In 2002-2003 I got the recharge well dug right next to the bore well with the idea that the bore well should not go dry. There has been no difference in the sort of working of the bore well before or after the recharge, but 21 years later I find that the discharge from the bore well is as good as it was in 2000. It's lovely to see the rainwater that collects and goes into the well. It's a pleasure to see the well filling up. every time there is maybe 15 to 20 millimeters of rain. It's just fabulous.
In Bangalore, we are trying to develop a map of the location of various open wells and the uses that they are put to in public parks, in individual homes, in apartments, in industrial areas, and in institutions like the Indian Institute of Management. We would solicit your assistance in improving and updating this map. The link will be provided, and make sure to get to the link and update through the app the location of an open well which you are aware of, so that we get a detailed map for open wells throughout Bangalore city. The parks of Bangalore have extensively used dug wells as the source of water when they were first set up. Lal Bagh began with 3 open wells and a Persian wheel to irrigate the gardens. Cubbon Park had 7 open wells. We were able to revive the 7 open wells in Cubbon Park, and we are reviving the open wells in Lal Bagh both through recharge as well as cleaning up the old wells which have been filled with debris and silt. Unfortunately, wells have been used as solid waste dumping grounds for many a year. We have to reverse that process by cleaning up these debris and garbage from the wells and bringing them back to life. Many parks in Bangalore can have wells brought back to life in such a manner which can provide them water for at least 6 months in a year. And through a process of recharge, these wells can be given an extended life too. This endeavor to focus on the open dug wells is to bring attention to the shallow aquifer, which is one of the most reasonable and best ways to prevent urban flooding by recharging the rainwater into the shallow aquifer, not allowing it to flow in drains and on roads, causing urban floods. So wells have many roles and functions, and reviving the memory of the well is crucial for India's water sustainability.
Thank you. You can write to us at water@biomesolutions.com if ever or whatever. Yeah. Done. Any other questions? Or I'm sorry? Complete 2025. And I was getting to the math of it. I was telling you why we can't do it. Because if I say 1 million, that's 10 lakhs, right? So if you just work it back, saying 365 days in a year, so let's say I take it as 300 also. Even if I did 10 wells a day, I'm only doing 3,600 wells in a year. And so in 10 years, I would have done only 36,000 wells. So obviously the rate has to be different if I have to get there, and the whole imagination has to be different. It's not me alone. Many more people have to do it. What is the rate? How do you track it? How do you track? So in a way, 1 million wells, also we have to keep in mind that it's a, it's a target arithmetically, not necessarily, because if you have a larger diameter well, it could be equivalent to 10 other such smaller wells. So all of those are nuances. So one is to build the enthusiasm around it. But I think the more important part, though we've set 2025 as our target. So because we can't keep saying forever that we are running this program. So 2025 is our target. Simple answer, but complex answer is that we wonder how are we going to get there, and what should be our approach, which is why you have to go very wide, and many times there'll be work happening that we don't know of. So right now what we're doing is, in the city there are 248 ward committees now. So each ward is looking after its particular area, and they have it's 1,200 square kilometers overall. So so if you work with the ward committee, for instance, one particular ward took up a 2,500 challenge, like you have the ice bucket challenge. They said we'll do 2,500 in 3 months. So they targeted it and they finished 2,500, and they just told us. So it's in these bits and pieces and very haphazard way, in a way that it can happen. Possibly can't happen in a very structured top-down way unless the government comes and says, okay, I'm going to dig. But what we've realized is when the government does it, something gets missed. So it has to happen. I mean, they'll just come naam ke vaste, because they'll give it to a contractor who has to dig 30 feet. He'll dig it in the most random place where there's no water going into the well, because he just wants to take his money and be done with the job. So you have to have this people participation. So even if slow, even if you don't meet your target, it's also important to get it right. So all participants have to work together. 2025 is our target. Done. Then all of you have a nice evening. Bye.
Thank you.